Hi folks, it's Ron. Hey, welcome back to another one of my segments on residential structured wiring systems. And actually, this is going to be part 3 of the series. And we're going to talk a lot about coaxial cables during this portion of it. And I'll talk a lot about the construction of the cabling and what to think about when buying coaxial cable and what to look out for. And I will, at the end of the video, talk a little bit about the tools and testing of the cabling. And I'll leave you guys to watch some of my videos on how to terminate it, because I have like about 18 videos up on how to terminate different kind of connectors and things like that. But in this video, primarily want to concentrate on the cabling itself. And when you look at cabling we're going to put into homes today, it's going to be a myriad of probably coax, category wire, or UTP type cabling. We also have speaker wire out there for audio systems, and of course, fiber optic cable is becoming more and more common in the home today. I don't know when it'll become real common, but we've been talking about fiber for years and years. But it is also something to think about. And of course, any other type of cabling we might put in the house, as far as sound and security cable, thermostat wire, all kinds of stuff, that's all classified as what by class 1, 2, and 3, and I'll cover that in another series somewhere down the road as to what that means. So, but in this video, primarily talking about coaxial cables. Now, when you talk about coaxial cables and really any type of a communications type cabling, that cable is made to a certain specification and is designed to perform at a certain specification. Now, when you hear the term RG associated with coax, it refers to as radio grade or radio guide, depending on who you want to argue with. But and it's an old, actually, military specification of what it is. And you should be aware of the fact that all these cables should be working at a certain, capacity, so to speak. And a lot of cable we get today, while it might say it's RG6, it's really not military spec cable, but it's something less than that. But you'll find an organization out there called the SCTE, if you don't know who these people are, and that's the Society of Cable Telecommunication Engineers. And if you want to figure out how cable does what it does, this is the group of people you're going to go to. And the great thing about the SCTE, and by the way, it only costs you $50 a year to be a member, and you can follow their blog and stuff like that. But one of the great things about the SCTE is that you can go onto their website and download the standard on things like F connectors and coax and splitters and other things like that. And it's interesting, they actually are trying to get the information out there to people. The bane to every cable and satellite company in a lot of cases is homeowners running out and buying low-end crap, which was fine 30, 40 years ago. But it's no good for today, and they install it into their system, and their system stops working. What do? They call the cable guy up and say, hey, your stuff's not working no more. And when really the homeowner was the one that caused the problem. And you would like to think the industry would not sell non-compliant stuff out there, but it does. And you cannot tell from the outside of a splitter if it's any good. You just cannot tell. You really need to look at the specifications on a darn thing. And it is interesting. I'm sure a lot of you guys have experienced where a cable guy comes into the house and, why does he cut every connector off that's not his, or he replace every splitter in the building that's not his? And the reason is because he knows his are good, and those others may not be. So just be aware of. So the SCTE is a great little organization to get to know if you don't know who those folks are, and you can learn a lot from their website. Now, when you look at a coaxial cable in itself, as I said, when I say RG6, it really doesn't tell me a whole lot about the specifications, because you'll find you can get this cable in all kinds of varieties, and I don't know how many hundreds of types of coax there are out there, but I know there's a bunch, and for audio applications, video applications, and other things as well. And they all have the same basic construction, but how much braiding they have in the shield and things like that, it can vary. And are they using solid copper or aluminum? All these things can vary in cable. So you almost have to look at the specifications on the cable itself to actually know what you have in your hands. But when you look at the construction of coaxial cable, it always has a center conductor to it. And that center conductor is typically either copper-clad steel or it's solid copper. And we can get away with copper-clad steel in the cabling because there's something in the cabling called skin effect. As frequency goes up in a cable, and the cable companies are working in hundreds of millions of hertz. This is not true on the low end, but on the high end, the electrons tend to travel through the outer parts of a conductor, and that's why we can get away with copper-clad steel. Steel adds strength to the cable, and we have a good surface that the electrons can travel down as well. Now, coaxial cable is considered to be unbalanced cable. And what we mean by that is that all the signal is traveling down the center conductor through that copper cladding. Okay. Now, the second conductor in the cable, which is the foil and the braid out there, is basically a zero reference point or a ground. So all the signal is traveling down that center conductor. Now, inherently with unbalanced cables like this, they are very susceptible to noise, which is why we shield them with the center conductor, with the second conductor there. So they're considered to be unbalanced, and you'll find category wire, for instance, is a great example of a cable that's actually balanced, where we're actually putting part of the signal down each of the two conductors and sending it down a cable, so to speak. So, and those kinds of wires are very resistive to electrical noise or outside interference. So coaxial cable is considered to be unbalanced. Now, the white part in that cabling is a dielectric, and it can be made of a lot of different things, but and actually the perfect dielectric is air, but we obviously can't use air. And its main job is to take and keep the two conductors exactly the same distance away from each other during the length of the cable. Now, so its main purpose is to keep the foil and the braid the exact same distance away from the center conductor. And if that varies in the cable from kinking it or bending it, or maybe in a manufacturing process, it's no longer right in the center conductor isn't, you can change what we call the impedance in a cable. And this is why we tell you don't kink it, don't bend coax. Is because the cable is considered to be 75 ohms of impedance, okay? And when we change that distance between the center conductor and that foil, we change the impedance of the cabling. So when we tell you don't knot it up, don't kink it up, we actually really kind of mean that kind of stuff. So don't be, the 8 to 10 inches of slack we get, we do not like to take the thing and shove it in the back of a box because you're going to be doing a little damage to the cable we don't want you doing, okay? Now, the other conductors in the cable, the foil is one of them. Makes up part of that, and the foil has a couple purposes to it. One is it's designed to keep outside noise, high frequency noise, from bothering what's going on in the center conductor. Okay, so it blocks out like RF signals, like if you live down the street from a radio station or something like that. And the other thing it will do for you is that as you put current down a conductor, it's going to radiate a magnetic field off that cable, and it's going to radiate out into the air. And the foil will help deflect that back onto the center conductor. So there's actually a couple of reasons for having it. Now, the other part of that second conductor is the braiding in the cabling. Now, that braiding, you can get in all types of types and flavors. Generally, it's aluminum, but it could be copper. Usually, 60% braiding is kind of industry average for cable TV applications, and what that means is that the weaving on it is covering up roughly 60% of what's underneath it, okay? But you can get it in 40%, you can get it in 90-some% braid if you care to. And the purpose of the braiding is to help keep low-frequency noise from bothering what's going on in the center conductor, so like normal AC signals. So, and the amount of braiding you get in the cable can vary quite a bit depending on the cable you actually pick up and buy. Now, coaxial cable, it gets its name from the fact that the two conductors in the cabling, which is again the center conductor and the foil and braiding, share the same center axis in the cabling, which is the middle of the cable. So hence the two conductors are coaxial. So you can go home and impress your loved ones with that knowledge tonight. But that's where the term coaxial cable comes from. But it's been around for a long, long time. And really, World War II and earlier than that. So the term RG, radio means radio grade or radio guide, I might have said, and you really need to look at the specifications of the cabling to know exactly what you have as far as that cable is concerned. But when you see a U, like in this case an RG-6 the U means universal. It doesn't mean underground. I get a lot of folks that think it's underground. And you'll find typically if a cable's designed to go underground, it'll have a clear gel in it or something like that to help make it watertight. But as a general rule, you don't see a lot of variable coax being laid out there. But as far as, to the drop to the house kind of thing, they just use regular RG6 typically. And typically that cable, RG6, typically has 18 gauge center conductors in it. As I said earlier, about a 60% aluminum braid to it as well. and the foil is glued or bonded right to that, and that's a typical shot of what a typical RG 6 cable looks like, as we've kind of looked at here in the past here, with a center conductor, the dielectric, the foil, and the braid, and of course an outer jacket, which is usually PVC, but it could be plenum or something else as well. And then we get into quad shield cable. Now, quad shield cable is the same thing. It's got the same center conductor, typically 18 gauge, but it's got two foils and two braids in it, so it's essentially double shielded. And you can get this in several variations of a percentage of braids covering what's going on in the cabling. And as a general rule, I'm going to tell you that you don't need quad shield cable inside of a single family home. Now, if you want to spend a little bit of extra money, 10 or 15 or 20% more, whatever it costs you, you certainly could, and it wouldn't hurt you none. And but if you are worried about electrical noise for some reason, well, maybe you do live right down the street from that airport or radio station, maybe you might want to go to a quad shield cable. So the only difference in the two cables is basically the amount of braiding or shields we have in the cables. Okay. Now you'll still find RG59 cable out there as well. And all these cables, by the way, are 75 ohm cables. You technically can splice a piece of 59 into a piece of 6 into a piece of quad, and they're all supposedly going to work together, but there's some more loss associated with some of these cables than others, but essentially they're all 75 ohms and technically interchangeable. And again, the TVs, the set-top box, all those devices are designed to be 75 ohm. Now, we normally find RG59 today regulated to closed-circuit TV applications. Security guys will use it. HD audio applications, those kinds of things. Cable TV companies don't use it anymore. They used it a lot in the 70s and 80s, but they've moved on to RG6, which if you can think of all these wires as pipelines, if you want to think about it, you got to understand something. In the 70s, we had a pipe that big, and we're putting this much information down the pipe. Today, we're stuffing this pipe, and so RG6 gives them essentially a little bit bigger pipe, so that's why they use it today. And in this particular RG59 you see on the screen here, it's got a solid copper center conductor. Sometimes these guys are powering cameras and things as well, and they need to have a little less voltage drop. And it has no foil in it, but it does have a 95% copper braiding in it, which is very expensive, and might run you a little bit more than RG6 does. But typically we'll pick a cable design for the applications, and RG59, RG6, and 6 quad are pretty common in cable TV applications. At least RG6 is in cable and satellite application. Now, a couple basic tips when you're pulling the cable and you're getting it into place. The standards recommend that copper-clad steel not be pulled any harder than 75 pounds of force. Okay. And solid copper at no more than 40 pounds of force. Now, how do you measure that? Well, you know what? Nobody measures it. But you kind of have an idea in your mind as an installer. If you're pulling on the cable a little hard and you stretch it a little bit, like I tell guys, if you ever pulled Romex and the outer jacketing of the Romex is like 3 feet longer than the copper inside, well, you pulled on it a little hard, but it still works. But you wouldn't want to do that to coax. You probably damage the cable to a point where you would want to use it. Bending radiuses. The bending radiuses are roughly 20 times the diameter of the cabling. So if a cable's about a 1/4 inch, the bending radius, 20 times is going to be somewhere around 5 or 6 inch loop is kind of what they're looking for at a minimum bending radius. As far as when we get it into place and what we call dress the cable, get it where we want it to be, no more than 10 times the diameter of the cable roughly. So it's interesting. They tell you don't kink and they don't bend coax, and they really do mean it today because again, we're stuffing this pipe like we never have, and we do not want to damage the cable in the process. Anytime you kink it like that, you're changing that, again, 75 ohms. Slack at the outlets is suggested to be 8 to 12 inches, and I said a minute ago, make sure you take that 8 to 12 inches and use a backless box, not a box with a back. Code does not require a back box on our low voltage boxes, so don't use them because people just wad up the cable inside the box. Separation from power is always a good one to ask folks, and anytime you see a number, it's more or less an opinion by some standard body or something like that. The only thing is law, which is the National Electric Code, it says 2 inches. Now, we know we like to say typically a lot further away from that. And I tell folk guys, as far away as you can get it is the best answer you can give people. But 2 inches is what code recommends. Now, if you look in red, the residential standard, the 570 standard, it's going to say 6 inches on coax, okay? And if you do run with catenary wire, keep it as far away as possible. Minimum 2, but at least 6 is what the standard is going to recommend. And if you cross it, we like to cross at 90-degree angles and keep it again 2 inches minimum off that, and cross at right angles to so that hopefully that noise from the electrical cable is not going to bother our coaxial cable. And I'll tell also, guys, one of the reasons low voltage guys need to be one of the last guys on a job site is because when you drill a hole in a wood member and you pass one coaxial cable through that little hole, and someone coming in behind you sees that nice hole in that wood member, they're going to go, hey, nice hole, and all of a sudden you get a piece of Romex pulled in that same opening. And so, again, to keep separation from power. Support the cable every 4 to 5 feet in like drop ceilings or attics or anywhere else you're going to run it. Do not have just two main points on a cable that's sagging 30, 40 feet kind of thing. Kind of funny, drop ceilings. You poke your head about above most drop ceilings in office buildings, and you'll find wires laying across the ceilings. But and of course, the ceiling's not there to support cable, but that's what happens. And again, as I said earlier, don't kink, don't bend. Cable ties, if you use them, don't cinch them up so tight you pinch the cable in the process. Standard Romex staples, they're fine as long as you don't pinch the living heck out of the wire. There's all kinds of staples designed for low voltage applications today, so I'd recommend you use those. Unfortunately, with Romex staples, you don't always hit the staple. You hit the wire too, which is not always, not, as I said, good. So, and then lastly, properly ground that coax, and you'll find all cable companies will put a gray little box on the side of a home, what's called the demarcation point. We've mentioned it before. And in that is a grounding bridge that's going to ground to the electrical ground on the outside of the house. So by code, we are required to ground all our low voltage cables, but in the coax, we just ground it once on the outside of a building. That's the only time you have to ground it. Okay? Now, signal loss in coax is actually fairly basic if you think about it. And it's called attenuation, if you want to hear the term for it. And so the attenuation of cable is caused by two main factors. One is the length of the wire, and obviously the longer the wire, the more attenuation or loss you're going to have in this cable. Okay. The second factor is the frequency of the signal, and we are working at very high frequency stuff. And a good analogy for you guys is sound traveling through air. Very similar to electrons traveling on a cable. If you're stopped at the red light at night and you hear the guy's stereo behind just being blasted, what do you hear? And you hear, of course, the boom, boom, boom. You don't hear the high-end portion of that music, and that's because it dissipates so much faster. So the higher the frequency, the more loss there is associated with this. So when you look at this chart, on the left side of that chart, it talks about the megahertz or the millions of hertz in frequency the cable company might be operating in. And they operate usually somewhere between 5 and 1 gigahertz in frequency, somewhere in that range. Usually a little under a gig in frequency. And will they ever go past a gig in frequency? And the answer to that is they can if they choose to. Right now they're not, but they could. The middle column, it talks about the dBs or loss in 100-foot length of cable. And the decibel is what it's called. And it's named after somebody. So that's, of course, old Alexander Graham Bell, who back in, I don't know, the 20s or whatever it was, took a mile of telephone wire. He measures the power coming in it, measures the power coming out of it, divided the two and took the log of it to create what we call logarithmic equation. And he named it after himself, the answer, and he called it 1 bell loss. And, well, a mile of wire is pretty long, a hunk of wire. We need a little shorter unit of measurement. So if you know your metrics, a deci is a tenth. So 10 dB actually make up a bell of loss. But the true dB is a power ratio, and we'll get more into the dB a little later on down the road. But I tell guys, if you don't know much about the decibel, go Google it, and you're going to find about 9 variations of it today. And it can mean different things to different industries, because not all industries measure power like Alexander did. And a good example is audio systems, as we mentioned a second ago. We measure sound in dB, but we measure sound pressure levels, or actually waves, sound waves. And in audio systems, 6 dBs represents a doubling or halving. And you'll see on this chart, 3 dB represents about a halving in power here. So actually, so in the bottom of this chart, at say 5 megahertz, the cable's losing only about a half a dB every 100-foot length cable. And 1,000-foot length, or 870 megahertz, I should say, we're losing over 6 dB, so quite a bit more. And these percentages on the signal loss on the right side here, try not to get too wrapped up in the percentages. At the end of the day, on the next segment, when we talk about how much signal loss do we have, and how do we measure it, we're going to add and subtract dB numbers to figure out if we have enough signal at the end of the day out of TV. So that's all we're going to do. So A little bit about the decibel, but there's definitely signal loss in the cable, okay? And to offset that, we can always go out and buy things like amplifiers. Now, amplifiers have changed quite a bit, and what they need to be able to do is change quite a bit in the last 30, 40 years, you know. And it's interesting, by the way, too, that cable companies typically give you enough signal on the side of the home you should never have to amp it unless you're doing something crazy like splitting it 8 or 10 or 12 times. And the reason they do is because if they only gave you the minimum they had to, most of us would probably end up buying an amplifier to amp the signal to whatever extra TV we're going to add. And unfortunately, we're going to go out and buy that $20 amplifier, not that $80 or $100 amplifier. And that $20 amplifier, which was fine 30, 40 years ago, is no good today. And it basically, in a lot of cases, those old amplifiers were not ready for a high enough frequency. They're not ready for digital high-def stuff. And they don't have much, if any, of a return path in them. And today, there's things like modems out there, and those modems need to talk to the outside world. Your set-top box needs to talk to the outside world, and it can't do that if there's not a return path in the cable. So signals are passing both ways through the cable. We call it bidirectional. So that's another term you're looking for on, again, an amplifier. So, and as a general rule, we would tell you to amp as good a signal as you can, which is usually before splitting it. Not always, but you can amp it really anywhere you want as long as you get a good signal to amp. And we'll talk a lot about that again in the next segment. And again, you'll find that the output rating as far as what it amps should be rated on the amplifier. And if it doesn't say it, that might be another indication it's not much of an amplifier. Here's an example of a pretty nice amplifier from our friends over at Leviton here. It's actually a 1x8. It's a 8-way splitter and an amplifier all wrapped up in one. It's actually adjustable. It's rated for a gig in frequency, which is kind of the minimum we want out of it. We want to hear the term bidirectional on the splitter as well. We want to see that it's rated for digital cable and HD TV stuff. And so just make sure if you buy amplifiers, they are rated for use today, and you should be okay. Okay. And when we go to test coax, as a general rule, all we test in the cable is for opens and shorts. And so here's an example of one of our what we call our voice data phone testers, or whatever, VDV is what we call it. And it just tests for opens and shorts in coaxial cables. And if you want something that measures signal strength, now that's a lot more money. And you're going to spend several $100s on something that might be able to measure the signal strength at the low end of the frequency, but it can't measure the signal strength at the higher frequencies. Those are a lot more money. If you see a meter that the cable guy's carrying around in the old backyard or something like that, that's usually about $1,500, maybe more, but that's a meter that can look at any channel, any frequency, and give a loss in the cable. But they're a lot more money. A lot of us will just hook up a TV to our thing, see if it's working. So, but as a general rule, just for opens and shorts. And so those testers can be fairly inexpensive. Now, the little connector we're going to put on the end of this cable is called an F connector, okay? And it took me 15 years to find somebody out who knew why they call them F connectors. And turns out, the little nut that spins on the front of a connector, it's called a ferrule nut connector. So there you go. There's the term. That's where the term came from. And there are a lot of different kind of coax connectors you can get out there, but F are very, very common in the cable and satellite world. And a dirty little secret about F connectors and a dirty little secret about a coax is that they don't always fit together, even though they're both RG6 or 59 or whatever it is. And what they don't tell you is that when they manufacture coax, RG6, 59, from manufacturer to manufacturer to manufacturer, they're not always the same dimensions necessarily. It's more of a guideline than it is an exact dimension it has to be, and so it's more of an electrical spec than it is a size kind of thing. And I'll give you a great example is component video cable. That's that red, green, blue wire you hook between a set-top box and a TV or whatever it is. If you ever cut that little cable in half, it's 1/8 inch in diameter, it's actually mini RG59, it's coaxed. So could you not make, say you needed a 50-foot long component video cable, could you not make it out RG6 and put RCA connectors on the end of that cable to make a longer component video cable? And you sure could, because it's all, again, it's all coax, it's all 75 ohms, so all interchangeable kind of stuff. You could if you care to. So I tell guys, the time to find out the connectors don't fit the cable you bought is not when you get to a job site. And there are going to be times when that connector goes right on that cable, and there's going to be times where it's not going on that cable. So just be aware of that. When we make a connector, we try to hit a range, but there are times when you might have to swap out connectors, okay? Now, when you look at the types of F connectors you can go out and buy, there's a number out here. To be truthful with you, only one of these is any good as far as the industry is concerned. But one of those is the twist-on, the one on the top here. And, if a guy is using a twist-on coax connector, are we going to call that guy a pro? I don't think so, because he can't even afford the tool to put the connector on. So twist-ons, the problem with them is they twist right back off, and you can yank them right up the end of the cable. They're not going to stay on. So twist-on connectors, homeowner fine, but as a general rule, no pro ought to be using one. And the second connector on that list is a crimp-on. And the crimp-on connector was the industry choice for lots and lots and lots of years. However, in the last, I'm going to say 10, 15 years, it's really come out of favor, and nobody recommends crimp-ons anymore. And for a couple reasons. One is the crimp connector, when it gets applied to a cable, the tool is going to crush that cable slightly in the process of applying that connector onto the wire. And secondly, the die in the tool will turn around connector into a hex-looking shape, and it has these little corners on it around the connector. And those little corners do a couple things. One, they let moisture get in and out of that connector, which I'm talking humidity corroding on a center conductor, which is a huge problem. And the other one is signal ingress and egress. Basically, signals can leak in and out of the connector. And as frequency goes up, we leak more energy. And these connectors are kind of considered leaky, so that's why your cable company no longer uses them. And they like to use compression coax connectors, which is the one on the right. We'll use everything nice and sealed and round and watertight and all kind of good stuff. So that's the connector of choice, okay? Now, the next connector on that list is a push-on. And, if I'm going to give the homeowner a toolless solution today, I'm probably going to give them one of these type of push-ons. And you strip the cable properly, and as the name implies, you just push it on and it stays on. And you can get them off, but it's a lot better than a twist-on, I'll put it that way. But the only connector up here that's any good is the compression connector you see here. And we sell an industry-compliant connector. Installed properly, it'll pass all the tests the SCTE says it has to pass in order to be approved by the cable and satellite companies. But you'll find that most satellite and cable companies have all gone out and spec'd one or two brands, and that's all they install. But we do actually sell a pretty good little connector right there. Now, when you cut the coax, I don't care what you cut it with, you're going to deform the shape of the cable in some form or another, whether you're using a diagonal or a side cutter or one of these rounded bladed cable cutters. Obviously, it's not good, and the stripping tool we're going to use on the end of the cable hopefully is going to remove anything we've really deformed, but about anything will deform the shape of the cable. But these rounded blade cable cutters don't do a bad job. Now, when you go to strip the cable, the idea is to create what they call a two-step strip, where you're exposing a certain amount of the center conductor and a certain amount of the braiding and foil here, okay? So in the industry standard is quarter inch and quarter inch of both. So quarter inch of center conductor exposed, a quarter inch of the braiding exposed. Now, these yellow-handled little what I call weekend warrior type tools, they work fine. I mean, they're you're not doing thousands of them. You get a couple done on a weekend kind of thing. You could use a razor knife, which just be careful not to cut through the copper coating of the center conductor. And if you want to go out and buy a little nicer tool, there are basically two types of coax strippers in my humble opinion. There's ones you can adjust the blade depths in, and there's ones you cannot adjust. And I'll be truthful with you, a lot of managers hate to hand their guys on a crew anything they can adjust, because what's the worst thing about adjustable tools? And that's, of course, that they're adjustable. But I tend to like them because I know that I can set that tool perfect for the hunk of coax I got in my hand, and I'm not going to damage something I don't want to. So the black one in the middle is what we refer to as clothespin style. They operate and open up like kind of an clothespin, and you can adjust the blade depths in them, okay? The one on the far left over there is an example of something you cannot adjust the blades in. And so with those kind of tools, you have to have kind of a feel for what you're doing with the cable when you strip it, because when they're brand new, you might only have to go around 2 or 3 times around the cable and it's done its job. But a couple hundred strips later, you might be going 4 or 5 or 6 turns to get the same cut. So with a tool that's adjustable, I can set that blade perfect so it won't go too deep if I don't go around too many times. Because with a tool like the one on the left, you go around too many times, you're going to remove most of this braiding, which is what you don't want to do. So so you kind of have to have a feel for what you're doing when you're working with the tools. Okay. Now, the compression connector we mentioned here, when you look at it, we sell regular RG6 quad. We also sell a universal. And this is an example of the universal. And it can work with regular RG6. It can work with tri-shield coax, which is a foil, a braid, and a foil. And also works with quad, which is full braid, full braid. So, but as I said earlier, be aware you might run across some cables that this might have problems with, but as a general rule, it really works pretty good on most manufacturers' cable. So one connector don't have to stock multiples of them. Now, if you're ever working with quad shield cable, you've got one more step to do in your stripping, and that is, excuse me, you're going to use the same tool to strip the cable. Excuse me. And it's going to create that two-step strip. Now you're going to fold back the outer braid of that first braid you find in quad. Now, right underneath that is a layer of foil. Now, that layer of foil is pretty much a continuous wrap around the cable. If you fold it back, it's going to bunch up so bad that you're not going to be able to get the connector over all this. So what we have to do is take it out. And you're going to find out the foil does kind of overlap itself someplace. So I'm going to find out where it's going to overlap. And then I'm going to take a diagonal or a snip or something and nip it right there. And then I can actually peel that piece of foil completely out of the cable and remove it. Now that exposes the second braid in the cable. So we're going to fold that second braid over the first braid in the cabling, and there's a properly prepped RG6 quad cable for a connector. You know, we get that call in customer service all the time. So people say, the connectors won't go over the wire. Well, you're not prepping the wire properly, so that's the problem. Now, the connector is called a compression. The reason is because the tool is going to squish it a little bit lengthwise together. So the connector will be a little smaller when you get done crimping them or compressing them. And the tool actually attaches to the jacketing and the braiding on the cable, so that's what it's actually attaching itself to. That back end should be completely watertight. You'll find there's an O-ring underneath the nut so that when you engage that nut in the mating half, it engages that O-ring and makes that nut watertight. And the only thing that's not watertight then are the threads. And if you don't crank them down tight, water can work its way down a thread. And you know, on the outside of a building, you'll find cable companies will actually torque their connectors down so to eliminate that problem. Now, you can buy boots too, but installed properly should work just fine. Okay. And when we go to compress it with one of these tools, you can go out and buy all kinds of different compression tools. As long as the tool compresses the connector completely together, any tool probably works. But this is our OmniSeal, and we have a series of these. And as a general rule with our tools, one setting for every connector we sell. And you can adjust the tools, which is nice because in somebody else's connector, you might be able to adjust it to use our tool on their connector. But with our connectors, one setting, and it will work with any of the connectors we have. And it's that large graduated mark you see there in the middle of the slide there. So that's one great thing about our tools. And you can buy, you know, versions of this that are under $20, and you can find versions of this that are, you know, $50, $60 or maybe more. And the first thing you do when you terminate a cable is you're going to put a connector, you know, strip the wire. You're going to fold back the braid like we talked about. Then you push the connector on. Now, it's very important that you push the connector on the cable until that white dielectric is even with that little hole in the bottom of the nut you see here. It's the number one thing I see people not doing when they're putting on connectors. They're not pushing the connectors on all the way. And hence, when they compress it, it comes off pretty easily. So, number one thing, and the reason is because that quarter and quarter thing in the strip we do, that quarter-inch center conductor is designed to be inside the mating half of the other side of the connector. So, and it's very important because if we obviously have too much center conductor, then you know we damage the connector, and if it's not enough center conductor, well, then you might not have much of any of a connection. So, now the tool is designed to compress the connector all the way down, and the tools are adjustable. And I get guys in classes that get about halfway down, the tool's been out of adjustment for some reason. And they're in the back of the room, squeeze as hard as they can on this darn connector or tool, and they end up crushing connectors in the tool. So be aware if you can do that. And you'll find on the connectors that right behind the nut is a kind of a big fat ring. And then there's a space between the sleeve and the back. And the tool is going to make that gap disappear on the connector. So we know the connector is completely compressed when that gap has completely gone away on a connector. And so there's a properly compressed connector on a piece of coaxial cable. All right. And two other basic connectors you'll find as far as coax is concerned are BNCs and RCAs. Now, the BNC connector actually is the original coax fitting, goes way back in the 20s and 30s, so it's been around for a long, long time. Military guys use them, ham radio guys. You'll find computer guys might use them. Security people use them a lot, obviously. They're a little pricey, and the other connector out there is called an RCA. And in the audio-video world, we use a lot of RCA connectors, which are named after that famous little company who in the 40s or whatever it was developed those phonographs, and we would use the speakers in existing stereos, so they developed that little connector. Now, both the RCA and the BNCs have pins in them, and so that's the center pin on an RCA. There's a little bit of pin inside of a BNC as well. F connectors are considered pinless. The center conductor actually is the pin. And we used to solder or crimp pins on those connectors. And you'll find that they're typically compression today, and we no longer have to do that. But those are two other connectors you'll run across when dealing with coax. Now, the hands-on on this portion of this series, I'm going to leave to my other videos I have up, and I'm going to post here a bunch of links to different videos that I have up. And if you go to my playlist on coax, you'll find like 18 videos on different connectors that we show you how to terminate and stuff like that. So depending on the connector you're trying to deal with, maybe you ought to go to that particular individual video. And while you're on my channel, do me a favor, go ahead and subscribe to it. And, you know, I can't believe, folks, the number of people I've been able to help with this darn channel. And so it feels good, and I really do appreciate that, and I appreciate you guys watching like you do. So thank you very much. Again, this is Ron with Ideal Industries, and I'll plan on seeing you on the next one.